So in this lesson, you're going to learn how to construct the unit circle. There's going to be really three overall parts that we fill in. And then once we fill this in, we're going to use it as a reference to help us find exact values. If you guys remember back in one of the problem sets, I had you use a calculator to find the value of like sine of 20 degrees or sine of 120 or cosine of 90. And now with the unit circle, we're going to be able to find certain values, trig values of certain degrees and radians without using the calculator. We're going to use the unit circle. But in this lesson, it's just to understand all the parts, because to look at the unit circle completed first is very confusing, very overwhelming. But we're going to slowly go through the parts and kind of break it down into little sections or categories. But in order to understand, there's going to be ordered pairs that show up on the unit circle, and in order to understand those, we need to go back and review special right triangles because they show up in the unit circle. So what I want you to first do is find the length of each side of the triangle that's missing here. So these are all special right triangles, and just to revisit that, when we're looking at a 45, 45, 90, each leg is going to be the same. So I'm going to call each leg x. So this is the ratio of the sides. And then the hypotenuse is x times radical 2. And then with a 30, 60, 90 triangle, the short leg is x. The longer leg is x radical 3. And then the hypotenuse is 2x. So pause the video, see if you can figure out the missing sides. Just to notice again in the first example here, we have 45, 45, 90, so that means both legs are the same. And then in the other two, they are 30, 60, 90. So go ahead and pause the video and see if you could figure out the missing sides. All right, so number one, or the first example here, each hypotenuse, if you notice, is 1. So to go from the hypotenuse back to a leg with a 45, 45, 90, we're going to take the hypotenuse and divide by radical 2. But then I want to rationalize this. So now I'm going to multiply top and bottom by radical 2. And then I get radical 2 over 2. So each leg here is radical 2 over 2 units long. Now that's very important, because what we're going to end up doing is putting this triangle in the unit circle and ultimately coming up with the ordered pair. So right here at the bottom left, if we consider this to be the origin, that means to go to this point up here, I'm going to move radical 2 over 2 units to the right and up. So I would have an ordered pair of radical 2 over 2, radical 2 over 2. So from the origin on the coordinate plane, I'm moving radical 2 over 2 units to the right, and then the same units up. All right, for the second example here, again, my hypotenuse is 1. So to go back to the short leg, if you look back up here, the hypotenuse is double the short leg, so the short leg would be half the hypotenuse. So that means my short leg is going to be 1/2. And then to get the long leg, I'm going to take 1/2 and multiply it by radical 3. So I just get radical 3 over 2. So that's my long leg. And again, if I were to look at this point right here as the origin, to get to this point up here, which would be on the circle, I'm moving radical 3 over 2 units to the right and 1/2 up. Like I said, we'll see these ordered pairs show up on the unit circle. Now, just the opposite here, because if I go back to the second example, if this is 30 degrees for this angle right here, that means this is going to be 60. So just the opposite, it's the same triangle, I'm just switching it around. So that means my short leg here is going to be 1/2, and then my long leg, I'm going to come up with the same fraction, radical 3 over 2. Now in problem set 4, I think it was, you guys were coming up with these values. It was either problem set 3 or 4, where I was giving you like cosine of theta is equal to 1/2. What is sine theta? And all of your fractions, all of your results either came out to be a 1/2, a radical 3 over 2, or radical 2 over 2. So this was kind of like getting you ready for the work with the unit circle. So we're going to come back and throughout our lesson here, show you how these triangles show up in the unit circle. What you're going to need for this is a way to draw a nice circle. So if you guys can go pause the video, but go ahead and find an object, some kind of round object, a small circle that you can trace, and follow along. If not, please just try to draw your circles as accurate as possible. All right, so we're going to sort of break this down into categories or families. So the first circle I want you guys to draw, and again, this is just over the X and Y, the coordinate plane here. So this is nothing more than the X-axis. This is nothing more than the Y-axis. And go ahead and just draw a circle and try to use, if you have a ruler, some kind of straight edge to draw the two lines here. So we're going to call this the axis families. Now, remember the radius of a unit circle is 1. And there's going to be 3 parts that we fill in for every marking on the unit circle. And the first is going to be the degrees. Then we'll mark the radians. So this is why we needed to understand how degrees and radians are connected. And then we have ordered pairs. All right, so first I'm going to go ahead and mark the degrees. So if I am right here on the unit circle, and again, all these points are just going to be on the axes. That's why we call it the axes family here, the category. So to start with, if I were to draw my initial side of an angle right here, I would be at 0 degrees. Then if my terminal side was also right here, again, that's just showing you I don't have any angle measures, so it would just be 0 degrees. If I were to draw my terminal side going straight up, this would measure 90 degrees right here. So it'd be at 90 degrees. If I were to draw my terminal side over here, I would have a measure of 180 degrees. If I were to draw my terminal side right here, this would be 270 degrees. Notice these are the markings I had on in the lesson on our axes here when we were sketching angles in standard position. And then if I were to draw my terminal side back over here, but I went all the way around, this would be 360 degrees. So there's all the degree markings, 0, 90, 180, 270, 360 for the unit circle. Now let's go back to the radian measure. So with radians, I'm going to mark this here just as 0, and I'm only going to label it here because 0 is the only time that we're going to see no pi values show up. But from looking at the previous lesson, 90 degrees, remember we did 90 over 1 times pi over 180. So this will give us 90 goes into 180 twice. So we get pi over 2. So this is pi over 2 radians. 180 degrees is pi. If we were to write this out, 180 over 1 times pi over 180, we're just left with pi. So it's pi radians. 270. Now we're not going to do this every single time, but if you ever forget a value, then know that you can always rely on this calculation. So 270 times pi over 180. Now 90 goes into 273 times into 180 twice, so we get 3 pi over 2 down here. And then if you remember from the very beginning, one full rotation is actually 2 pi radians. So here we have the radian values. We have 0 radians at 0 degrees. Pi over 2 is 90. Pi is 180. 270 is 3 pi over 2 radians. 360 degrees is 2 pi radians. So we have our degrees written out. We have our radians. Now for the ordered pairs, because our radius is 1, if I were to just go straight out over to this point, and this has a length of 1, my ordered pair right here, I know I have a lot of information filled in here, but this would just be the ordered pair 1, 0. If you're looking at this is just one marking, I'm going 1 to the right, up and down, none. So if I go up here, again, this would have a length of 1. This would be the ordered pair 0, 1. Over here, I'm going 1 to the left, so we would have a negative 1, 0. And then down here at this point, this would be 0, negative 1. So on the coordinate plane, I have my ordered pairs, but looking at the rotations of the unit circle, I have both the degree measure and the radian measure. Now those ordered pairs are going to come into play here in a little bit. All right, go ahead and draw another circle with the axes drawn in. But now our terminal side is going to be halfway in each quadrant, and I'll kind of re-highlight these as we go over them. So we are halfway in each quadrant. So if this is my initial side, this is going to be my first terminal side. Now halfway in each quadrant, if it's 90 degrees up here at the top, this would be 45 degrees right here. And then this is where our special right triangles are coming into play, because if I go straight down from here, I actually have a 45, 45, 90 triangle. So this is where the triangles, the special right triangles, are going to show up in our unit circle. So right now, I'm going to first write out the degrees. So I have 45 degrees as a full rotation right here. If I were to look at the terminal side in quadrant 2, this would be 45 degrees. 45 degrees would bring me up to 90, and another 45, I'm actually at 135. So this is where like those nice fractions come into play. So if each little piece of the pie here, if you look at this, is 45 degrees, that means 45 times 1 times 2 times 3 is 135, and it's a nice way to also learn multiples of 45 a lot quicker. All right, another halfway would be right here in the third quadrant. So if I went all the way around, now this is 1, 2, 3, 4, 5, 45 times 5. If I also look at this being 180, 180 plus another 45 would give me 225 degrees. And then one more, I'm halfway in the fourth quadrant. So if I went all the way around here, this would be 1, 2, 3, 4, 5, 6, 7, 45 times 7. But if you also know that this is 270 down here, 270 and another 45 would bring me to 315. So I have the degrees written in for halfway in each quadrant. Now, I'm going to take 45 degrees. I'm just going to do this once. Multiply by pi over 180. So if you remember, 45 goes into 180 4 times. So I'm going to get pi over 4. Now this is what's nice, because if we're looking at all of the radian measures in the middle, we're going to get the same denominator here of something pi over 4. So 45 degrees is equal to pi over 4 radians. Now we don't have to keep doing this using the calculations off to the side. 135, how many 45s do I have here? And I'm just going to show this extra step here. So I'm going to have actually 135 times pi over 180. Now 45 goes into 135 3 times. We can count the sectors here, the pieces, the wedges. So it's going to go into 135 3 times and into 180 4 times. So I actually get a 3 pi over 4. So I get 3 pi over 4 radians for 135 degrees. So notice they're still both something pi over 4. The denominators are going to be the same halfway in each quadrant. And I actually have 1, 2, 3 sections of 45. So there I get my 3 pi over 4. So down here at 225, I'm still going to get a something pi over 4. And if I count the sections, 1, 2, 3, 4, 5, that will give me a 5 pi over 4. Pause the video real quick and see if you could think of what pi over 4 we'll have for 315. So if you count them, again, 1, 2, 3, 4, 5, 6, 7, this will give me 7 pi over 4. So 45 goes into 315 7 times, so we get 7 pi over 4. So halfway in each quadrant is the pi over 4 family. But notice the different numerators that we're getting here. We really have a 1 pi over 4. Over here in the second quadrant, we have a 3 pi over 4. Then we have a 5 pi over 4 and a 7 pi over 4. So notice we're going 1, 3, 5, 7. They're all odd values here, increasing by 2 each time. So that's another nice thing you're going to start to see with the unit circle. So many different patterns show up as a quicker way to memorize than always taking a look at the calculations to always convert. So we're going to get through this a lot quicker. Now when we go to look at the ordered pairs, I'm going to go back to this first triangle here. Notice it's 45, 45. Notice the ordered pair here. So I'm going to take a look at this. So if I were to trace this part right here, that's a length of radical 2 over 2. And then I'm also going up radical 2 over 2. So this ordered pair right here on the circle is radical 2 over 2, radical 2 over 2. I'm at the same location in each quadrant, my signs are going to be different. If I were to travel over this way to the left, I'm going to go radical 2 over 2 units to the left, so it's going to be negative, and then up radical 2 over 2 units this way. So here I have the same ordered pair, except the sign of the first number is going to be negative. In the third quadrant, the lengths again are still the same, but if I'm in the third quadrant, both the x and the y coordinates are negative, so this is going to be the ordered pair negative radical 2 over 2, negative radical 2 over 2. And then in the fourth quadrant, my first number is going to be positive, but my second number is going to be negative, so this is the ordered pair radical 2 over 2, negative radical 2 over 2. All right, so we have the degrees, we have the radians, and we have the ordered pairs. And then this is the piece that ties everything together as well. Any point on the unit circle can be defined as cosine theta and sine theta, where theta is the central angle. So in other words, looking up here, I'd have theta as my central angle, as whatever rotation I'm looking at. So just to practice this, I want to go back. And if you guys get out your calculator here, I just want you to type this in. Make sure you're, and we could switch modes here real quick. So make sure you're first in degrees. And if I wanted you to type in, let's say, sine of 270, see what you're getting here, you should get a -1. And if we look at the ordered pair, that's the second number. Type in cosine of 270. That should give you 0. That's the first number. So this is how the ordered pairs are going to help us calculate trig values without using the calculator. If you were to switch to radian mode and you type in sine of 3 pi over 2, you should get -1. So if you want to type in a value with a pi, you have to switch your calculator to radian mode. And in the upcoming lessons, I'll show you guys how to do that. If it's on the Desmos calculator, it should be pretty easy. All you have to do is hit the degree button, and then I will show you guys if you have your own Inspire calculator. It's in the settings that we have to go through. All right, but let's first finish all the pieces of the unit circle. Next, we're going 1/3 of the way from the x-axis in each quadrant. So these are also like reference angles. We're 30 degrees, because 1/3 of 90 is going to be 30. So we're drawing this up. It's going to be 30 degrees. So go ahead, redraw a circle, draw in your x and y axes as well. So if I just started, again, with labeling this as just 30 degrees, 30 degrees up from 180, this would give me 150 degrees. 30 degrees down from 180 would give me 210. And 30 degrees before 360 will give me 330 degrees. So I have the degree symbols written in. Now going back to our special right triangle, we could draw this in. We'll get to that though when we go to draw the ordered pairs, but this is how else we could look at it. Before I do that, I want to sketch in the radian measures here. So I'm going to take the 30 degrees once, multiply by pi over 180, and 30 goes into 180 6 times. So this is going to give me a 1 and a 6. I'm actually going to be at pi over 6. So this is the pi over 6 family, meaning all of our denominators are going to have a 6 in it. So this is actually going to be just pi over 6. Now, how many times will 30 go into 150? That's 5. So this becomes 5 pi over 6. How many times will 30 go into 210? 7. So this gives me 7 pi over 6. And then how many times will 30 go into 330? That's 11. So this is 11 pi over 6. So we could get to the radian measures a lot quicker. If we know that 30 degrees is pi over 6, then we could just multiply by how many times 30 goes into the degree measure here. All right, now if you notice here, this is 1, 5, 7, and 11. So between 1 and 5, that jumps up 4. Then this only jumps up 2, and then it jumps up 4 again for the numerator. So different ways to tell the patterns. All right, now to figure out the ordered pairs, and again, going back to our second triangle right here, when my central angle is 30 degrees, I want to go radical 3 over 2 and then up 1/2. So this is the ordered pair I'm looking at when this angle is 30 degrees. And I call this the longer leg. That's radical 3 over 2. My shorter leg is 1/2, so my ordered pair here is going to be radical 3 over 2 and 1/2. So my longer leg of in the unit circle of a special right triangle is always going to be the radical 3 over 2. The shorter leg is going to be 1/2. In the second quadrant, it's the same values except the first number is negative, so I get a negative radical 3 over 2, 1/2. Third quadrant, they're both negative, so negative radical 3 over 2, negative 1/2. And fourth quadrant, first number's positive, second number's negative. So again, on your calculator, let's just keep it in degree mode. Let's go ahead and type in cosine of 30 degrees. Now, depending on what calculator you have, it might give you a decimal, but cosine of 30 degrees is going to be this first number, radical 3 over 2. Which is approximately 0.866. So if you're getting 0.866, that's radical 3 over 2. Go ahead and type in sine of 30 degrees. That's going to be our second number. You should get a 1/2, either a 0.5 or 1/2. So again, we're going to use our unit circle to get the exact values here. But just to point out, when we're on the unit circle, sine of an angle or sine of a radian measure is going to be the first number of the ordered pair. I think I said cosine of that will be the first number of the ordered pair. Sine of a degree measure or a radian measure is going to be the second number. So again, cosine theta is equal to the first number. Sine theta is going to equal the second number. All right, we've got one more family, and then we're going to kind of reconstruct the entire unit circle. And then I'm going to keep posting different lessons of just going over this just to practice generating this. All right, so let's do 2/3 of the way from the x-axis. So 2/3 of 90 is actually going to be 60. So when our central angle is 60, we have 60 degrees up here. So go ahead, pause the video, draw yet another circle, and fill in, draw on your axes. All right, so we have 60 degrees here in the first quadrant. And then if we're 2/3 away, so we're 60 degrees away from 180, that would make this second measure here. This would be 120. If we're 60 degrees past 180 in our third quadrant, that's going to be 240. And if we're 60 degrees away from 360, we're going to be at 300. So these are all the degree measures that are 2/3 away from the x-axis in each quadrant. To start, if I took 60 over 1 multiplied by pi over 180, 60 goes into 180 3 times. So I get pi over 3. So this is all pi over 3 family. All of our denominators will be 3. So this is pi over 3. 60 goes into 120 twice, so this becomes 2 pi over 3. 60 goes into 240 4 times, so this is 4 pi over 3. And 60 goes into 300 5 times, so we get 5 pi over 3. So the connection here is, notice this is 1/3 pi or 1 pi over 3, 2 pi over 3. So these are just one away from each other. And we jump up 2 again. We get 4 pi over 3 and 5 pi over 3. 4 and 5 are just one away from each other. All right, looking at the ordered pairs, this again is a 30, 60, 90 triangle, but 60 degrees is the central angle. So this is the short leg now. This is 1/2. This is radical 3 over 2. So it still has the same values as the last example, except the numbers are switched. So this is now the ordered pair 1/2 and then radical 3 over 2. Over here, same numbers, first number's negative though, so this is going to be negative 1/2, positive radical 3 over 2. Down in the third quadrant, they're both negative, so negative 1/2, negative radical 3 over 2. And then in the fourth quadrant, first number's positive, second number will be negative. All right, so let's just check this. On your calculator, go ahead and type in cosine of 120 degrees. That's our first number here, so that should give us a negative 1/2. Type in sine of 120 degrees, and you should get that 0.866 number, which again is radical 3 over 2. So again, as an ordered pair, cosine of whatever degree or radian measure is going to be the first number. Sine of our degree or radian measure is going to be our second number of the ordered pair. All right, so I'm going to post this as a PDF. It looks like this. This is what I would normally, if we were still in class, have you guys fill this in, a couple homework problems, give you blank sheets of this, and then I would give you guys a test, a short quiz that you'd have to fill all these in. So what I first want to do, take this in pieces here. So on the next page, and I'll post this as a PDF so you guys can actually print this out as well. So if you've seen that ahead of time and you want to print this out to fill it in, that's fine. If not, just try your best. Draw a really large circle. We're going to fill this in piece by piece, but in each quadrant you want to have sort of like these middle 3 lines going up for the radius here for each one. So pause the video, go ahead and construct this if you're not able to print this out as best you can. All right, so first we want to go through and fill out the degrees and kind of notice a pattern with the degrees. So right here, when I'm right on the positive side of the x-axis here, this is going to be 0 degrees. Then I'm going to jump up. This is a third of the way in each quadrant, so this is 30 degrees. Next, I have the middle of each quadrant. Each quadrant measures 90 degrees, so this will be 45. Then I have 2/3 of the way, which is 60 degrees, and then at the very top I have 90. Now let's see the pattern of how these are changing. I go from 0 to 30, 30 to 45, which is 15. Another 15 gives me 60, and then I have another 30, which is 90. So I go 30, 15, 15, 30, and that's how I add the degrees each time. So to go from 90, I'm going to jump up 30, which is 120. Now I want to do a 15, so that's 135, which is in the middle of the second quadrant. Another 15 will give me 150, and then another 30 will give me 180. So it's 30, 15, 15, 30 that we add each time. Next, another 30 will give me 210. Another 15 will give me 225. 15 will give me 240. And another 30, I'm at 270. Add another 30, I'm at 300. Add 15 onto that, I'm at 315. Another 15 will give me 330, and then another 30 will give me 360. So each quadrant, the degrees increase by 30 from the axis, 15 in the middle, another 15, because you can see how much closer they are together, and then another 30 at the end. So we have all the degree measures written out. For the radians, again, I'm going to do this by the families. I'm going to start with the axes. This is why we learned them this way. 0 degrees is 0 radians. 90 degrees, I'm halfway over. 180 is pi. I'm halfway over to pi, so this is pi over 2 radians. Coming down to 270, I'm 1.5 of pi here, so this is going to become 3 pi over 2. That might be the tougher one out of all of these to try to remember. And then at the very end, I rotate. Remember, it's 2 pi. So this is really saying 0, 1/2, 1, 3 halves is 1.5, and then I'm at 2. So there's my radian measures for the axes. The next family we learned was the halfway in each quadrant. That was the pi over 4 family. So at 45 degrees, I'm going to say pi over 4. Next, in the middle of the second quadrant is 135. Well, 45 times 3 is 135, so this is 3 pi over 4. At 225, that's 5 times 45, so this becomes 5 pi over 4. And then at 315, that was 7, so I get 7 pi over 4. So the pi over 4s, remember how they jumped up? They jump up 2 here, another 2, another 2, so 7 pi over 4. All right, let's go with the 30 degrees, so we're a third of the way. Remember, this is the pi over 6, so I'm going to get pi over 6 here. Next, 30 degrees above 180 is 150, then 30 times 5, so I get 5 pi over 6. Next would be 210, 30 degrees away from 180. 30 goes into 210, so I get 7 pi over 6. And then 330 is 30 degrees away from the x-axis in the fourth quadrant, and 30 times 11, so I'm going to get 11 pi over 6. And then last we have 60 degrees, so that was pi over 3, because 60 goes into 183 times. 120, 60 goes into 122, so this is 2 pi over 3. Next I have 240, 60 goes into 244 times, so I have 4 pi over 3. And then last I have 300 degrees, which is 60 goes into 305, so I get 5 pi over 3. And then I forgot 360, which was, no, I still have that there as the 2 pi. All right, so these are all the radian measures. Another pattern I want you to look at, in the first quadrant, notice all the numerators up to 90 degrees, they're all 1. So we got 1 pi over 2, 1 pi over 3, and then look at the denominators. So imagine And the easiest way I could describe this are quiz scores. So if you got a 1 out of 6 versus a 1 out of 4, you're improving. 1 out of 4 is better than 1 out of 6. 1 out of 3 or 1/2. So 1/6, 1/4, 1/3, 1/2. So all of the numerators are 1, and then we go 2, 3, 4, 6 as our denominators. In our second quadrant, notice each numerator is only 1 less than the denominator. We get a 2 pi over 3, 2 over 3, 3 over 4, 5 over 6. So kind of like our quiz scores are improving a little bit better. 2 out of 3 is a lot better than 1/2. 3 out of 4, that's actually 75%. 5 out of 6 is actually an 83%. But they keep getting closer to 1, and this is where we hit 1 pi. Now take a look at 7 pi over 6. If you got a 7 out of 6 on a quiz, you're over 100%. You're past 1. But notice again, now these are all 1 larger. So in the second quadrant, each numerator is 1 smaller than the denominator, but as soon as we cross 1 pi, now we're 1 larger than our denominator. 5 compared to 4, 4 compared to 3, 3 compared to 2. But now in our fourth quadrant, it changes a little bit. There might not be an easy way to kind of notice this, because here we're 2 larger, we're 3 larger, and then we're 5 larger, so it doesn't really make too much sense. But notice here as we approach 2 pi, 5 is very close to 6, and 6 is double the 3. 7 is just 1 away from 8, and 8 is what we get when we double 4. 11 is just 1 away from 12, and 12 is what we get when we double 6. So each of these numerators are just 1 less than double our denominator. So those are different ways that we could look at these. And then finally, let's go ahead and write in the ordered pairs. Again, going back to the axes, we have a radius, which is 1. So on the axes here at 0 degrees, we're at 1, 0. At the very top at 90, we're at 0, 1. Over at 180, we're at negative 1, 0. Down at 270, we're at 0, negative 1. Next, because they're going to be the same values, are the pi over 4 family. This is the 45, 45, 90 triangle, which involves the 2. So we get radical 2 over 2, radical 2 over 2 in the middle. We're going to get that the same in each middle ordered pair, but the signs are going to change. So in quadrant 2, we're going to get a negative radical 2 over 2, positive radical 2 over 2. Third quadrant, they're both negative, radical 2 over 2 negative for the first one, negative radical 2 over 2 for the second. And in the third or the fourth quadrant, first number's positive, second number's negative. All right, now the last sets of ordered pairs all involve a 1/2 or radical 3 over 2. It just matters what order. So when we're at 30 degrees, we have to go over longer and then go up shorter. So the longer of the two fractions is radical 3 over 2 and then 1/2. Over in the second quadrant, we're going to go negative radical 3 over 2, positive 1/2. In the third quadrant, we're going negative, for both of them, negative radical 3 over 2, negative 1/2. And in the fourth quadrant, we're going over positive radical 3 over 2, negative 1/2. And then we simply switch these. So if 30 degrees is the radical 3 over 2, 1/2, 60 is 1/2 radical 3 over 2. Second quadrant, we're going to get negative 1/2, positive radical 3 over 2. Third quadrant, they're both negative, negative 1/2, negative radical 3 over 2. And then fourth quadrant, first number's positive, so positive 1/2, negative radical 3 over 2. These positive and negatives down here we're going to talk about in a later time. But then we have our 3 pieces, the degrees, the radians, the ordered pairs. So what I want you guys just to focus on today is try to reconstruct this, again, just basing it on these 3 parts to fill those in. Look at the families again, go over it slowly. I'll post this as a separate PDF, a blank copy here that I want you guys to practice filling out. Again, if you can't print it, just redraw the unit circle as best you can and very neatly try to fill this in. So the larger you make it, the more room you're going to have. Over our next couple lessons, guys, I'm going to go revisit this and we're going to figure out exact values, and that would pretty much wrap up the extent of how much further we're going to go in this course. But it's going to be all of next week as well to look at exact values, and then I'm going to give you guys a final quizzes over trig values, converting from degrees to radians, unit circle values to help us with those trig values. As always, take care. Let me know if you guys have any questions.